In this video, we look at an example of a arc-length line integral. So this is an example, an integral along a curve of some function f ds. And what we have in this problem is that our function is a function of two variables. Okay, and we have a curve c given parametrically by r of t is equal to 1 plus 2t, and then y is equal to t, and we're told to integrate from time 0 to time 1. Okay, so what we're asked to do in this problem is to do the arc length integral. We're integrating from time t equals 0 to time t equals 1. We're integrating along this line segment. We need to find the scalar function along the curve, and then we need to multiply that by the magnitude of the velocity and integrate with respect to t. So we're integrating from time t equals 0 to time t equals 1. Okay. The function along the curve, wherever you see the x, put in a 1 plus 2t, and wherever you see the y, put in a t. Okay. And this is, whoops, sorry, forgot the magnitude of velocity. And the velocity here, v of t, is equal to 2 comma 1. So the magnitude of the velocity is the square root of 5 dt. Okay? And this is the integral we need to compute. Okay? That integral can be split. Actually, let me make a note for myself here, and then I will write this down, and then we'll switch to another page. So I'm going to write down that integral. Okay, and then we'll switch to evaluating it on the next page. Okay, so let's add a page below, and we will now try to tackle this integral. These are basically just calculus 1 integrals, so you need to try to remember your techniques like u substitution or integration by parts, or any of the calc 2 kind of integration techniques, trig substitution or whatnot. So let's see how we would handle this integral. I can see this being split into two integrals, t equals 0 to t equals 1, square root of 5 over 1 plus t squared dt plus the integral from t is equal to 0 to t is equal to 1 to square root of 5t over 1 plus t squared dt. Okay, one of these integrals is a pretty straightforward one. Okay, the first or the second integral. And I am thinking that it is the second integral because this is a u substitution integral. I always think about u substitution first. If you let u is equal to 1 plus t squared, then du is equal to 2t dt. Okay? So making that substitution into the second integral, t is equal to 0 to t is equal to 1. 2t dt is equal to du. 1 plus t squared is equal to u. Okay, and then we need to switch to our u limits instead of t because we're doing a du problem. So this would be u is equal to 1 up to u is equal to 2. Just substituting t is equal to 1 into here, and you get u is equal to 2. Which means that our integral is going to be square root of 5 logarithm of u, evaluated from u is equal to 1 to u is equal to 2, which is square root of 5 logarithm of 2 minus logarithm of 1. Logarithm of 1 is 0. Square root of 5 logarithm of 2 is that second is the second integral. Okay. The first integral looks like one of those problems that we should know from Calculus 2. And I will let you look that up in a table, or I can show you how to look at Mathematica. Let me bring in, Mathematica here. File, new notebook. Okay. Change the font up here. And basically what you have to remember is the integral of 1 over 1 plus t squared. Okay. That's either the arctangent, the arcsine, or the arccosine, or one of those integrals. Okay, so we could do a trigonometric substitution on that problem by letting t squared equal to probably tangent squared, and then working the problem out. Or you can ask the computer to help you double check that integral. Oh, we don't want an indefinite integral, and let's ask ourselves what was 1 over 1 plus t squared, the integral with respect to t. And there is your arctangent integral. Okay, so that would have come about from a trig substitution. Okay, so which means that this second integral here is going to turn out to be square root of 5 inverse tangent of t evaluated from t is equal to 0 to t is equal to 1. So you'll get square root of 5 inverse tangent of 1 minus inverse tangent of 0. Inverse tangent of 0 is 0. Inverse tangent of 1, what angle has a tangent? Inverse tangent of 1 is another way of saying tangent of what angle is equal to 1. And I think that should be pi over 4. You can ask for the arctangent of 1. You get pi over 4. Okay, so you will get square root of 5 pi divided by 4 minus square root of 5 logarithm of 2 is the answer for the problem that we just did. Okay, so this answer I have in the box is the answer to the line integral of x over 1 plus y squared along this particular line. Okay, the next video will give you a geometric interpretation of this